Raz, dwa, trzy, cztery.
Mikser, tak. Dzień dobry Państwu. Witam wszystkich Państwa bardzo serdecznie na naszej stacji doświadczalnej w Skierniewicach. Bardzo się cieszymy, że Państwo przyjechali do nas. Mamy nadzieję, że konferencja była dla Państwa owocna i udana. Tak, zaraz. I would like to welcome all of you in our experimental station in Skierniewice. Thank you very much that you are here with us, and it's very important for us to show you our station. I hope that the conference was very fruitful for you, and you had nice time. Okay, I would like to welcome you in our station. I would like to also invite all of you, but also I would like to invite the director of the station, Paweł Szacki, the head of the station. I would like to invite vice director of the institute, Stanisław Samborski. I would like to invite dean of our faculty of agriculture and ecology. Professor Irena Suwara. I would like to invite Professor Wojciech Stępień, who was the head of the station before Paweł for about 20-30 years. 20-30 lat, tak? Pan profesor był kierownikiem. 25 years. So, I would like to invite also all the emeritus professors. Professor Jan Łabętowicz, who was the dean of faculty, and he also contributed to the look of the station. I will tell about this a little bit later. I would like to also invite Professor Sławomir Podlaski, who was also a dean of our faculty in the past. I would like to invite all emeritus professors from the institute, and all of you. Okay. At the beginning, I would like to tell you something, and I would like to convince you that our station is something which is unique, something special. The station official name is, like you see here, the Professor Marian Górski Experimental Station in Skierniewice. This is one of the units of my institute, Institute of Agriculture, Warsaw University of Life Sciences. We have 5 units, the Department of Agronomy, Department of Biometry, or Department of Soil Science, Department of Agriculture and Environmental Chemistry, and the station is the 5th unit of the institute. The station was founded by these two people. Very important. These are very important people for our university. On the left, you can see Professor Józef Mikułowski-Pomorski, who led to the situation that our university was given the farm here, yeah, in the Skierniewice. And also he set up the first part of our experiments. Marian Górski developed this, and both men worked in 1920s. Yeah, so these are the main people for this station. These are the founders. Why the station is unique? First of all, due to the long-term experiments. Some of you were on the balcony and you saw this. Here there's a look from a drone. You will see these experiments in our trip. Tomek Nieciński in a minute will tell you some details. I will just do some background of this. Our experiments are divided into 3 parts. One part we call it A and AF fields. These are 13 fields. Yeah. A little bit further, we have monocultures, 3 monocultures. Monoculture of potato, the oldest potato monoculture all over the world. Monoculture of rye, D6. Potato is D5. D6 is a rye monoculture, the second oldest monoculture all over the world. And D7 is a monoculture of triticale from 1980s. It is also the oldest triticale monoculture all over the world. And on the left, you can see the 5-field crop rotation. This is some kind of sustainable crop rotation, an example of such a sustainable crop rotation with 3 grain divided by potato and legume. Potato is also used with farmyard manure. So, and every 5 years there is a farmyard manure on the field. Here you can see the look of the A1 to AF3 fields. So we can see here 8, 9, 10, 11 fields. Here we have arbitrary crop rotation with different plants on different fields. And parallelly to this, we have the experimental fertilization combinations, as you can see here. Yeah. Here, in this case, we can see 6 combinations repeated 3 times. So here we have fields with 3 repetitions. The station is also unique because we have a meteorological station here, which is 100-year-old. So this is it is as old as our experiments. So we have meteorological station in the central part of our field, and we can have the weather data exactly from our field. Yeah. This is the station belonging to Instytut Meteorologii i Gospodarki Wodnej, Institute of Meteorology and Water Management. This is governmental network of meteorological stations. But the data are freely available on the website. Our station is also unique because we have, I think, the only one in Poland. Such facility, I mean the Hall of Agricultural Experimentation History. It was a hall which was opened in 2021, and it was organized by Professor Andrzej Radecki, which is absent today, Professor Jan Łabętowicz, and Professor Wojciech Stępień. You will see it also during the trip, and the details will be given later. And also, the station is unique because during the World War II, So during the occupation of Nazi Germans, a unit of our home army, we call it Armia Krajowa, stationed here, and so this is a place very valuable from historical point of view. Yeah? And you will also hear the history about it later. The current state, so what we can see now is an effect of work of many people since 1920s. So a few generations worked to develop our station. The oldest buildings are this building, the building number 1, and this is the building where there is a bureau of the station, the house of the head of the station, and small laboratory. And the second oldest building is this one. This is old granary, in which we have this hall of agriculture experimentation, history of agriculture experimentation. This is here. This building is a garage and workshop, and this building is the building in which we are now. We are exactly here in this part of the building. So in this building there is this hall, conference hall, and also the rooms for our workers, and also the rooms upstairs used, for example, by students during the practices and so on. And also on the right you can see the experiments divided into plots, 3 per 9 meters. Today also you will hear the information. You will get the information about the other long-term experiments conducted in our institute. They are located not here in Skierniewice. You will hear about the Chylice fields. Chylice. This is the field. These are 2 fields about 30 kilometers from here. We will not see it in the field. Aneta Peszanowska will tell us about it. Tomek Niedziński will tell us about Skierniewice. And also we will hear about our youngest agriculture experiments conducted in 2011. So they are actually 15 years old in Miedniewice. Beata Michalska-Klimczak will tell you the details about this. I forgot to tell yesterday that apart from 100th anniversary of Skierniewice fields, actually we are also in a time when we have also another anniversaries. The fields, I will go back. The fields in Chylice were set up in 1955. This one. So we have actually 70th anniversary of these fields. And the upper field, these fields are fertilization experiments. These fields are tillage experiments. The tillage experiments were set up in 1975. Yep. So we have actually anniversary, 50th anniversary of these fields also. And Miedniewice were set up 15 years ago. So actually we have 4 anniversaries in one time. That's why we would like to also tell you something about Chylice and Miedniewice. Okay, so the purpose of our meeting is to, first of all, to provide the information about our long-term experiments in Skierniewice, Chylice and Miedniewice. It will be in a minute. Tomek, Aneta and Beata will show you this and tell you about it. Then we will go to the conclusion of the conference. So we will, I hope we will get some discussion. I will go back to the answers asked, the questions asked yesterday. Also, our major aim is to show you the fields. Yeah, to show you the fields in Skierniewice. So we will present it in the field. I think that the weather will be better and better. I think so. We will show you the fields. We will show you the soil profile. We will also invited 2 companies, and we will show you some innovative techniques for identification of status of plant nutrition, developed by Polish scientists, Professor Kaladzi from our university and the company QED company. Yeah. Our fields are perfect place to show which the status of plant nutrition, yeah, due to the different combinations, different mineral fertilization combinations. Lunch is planned between the after the conference closure, yeah, and the trip somewhere here about 12:30. And as for the trip, you will go, you will see the trip, you will see the fields. You can take this map somewhere. This map is somewhere here. You can take it and you have it in the field. We will show you the A fields, AF fields. Here there is a soil profile. I will show it. The meteorological station is here. We will also take you to our monocultures, D5, D6, D7, and 5-field crop rotation experiment here. And you will also see the whole of agriculture history, agriculture experimentation history, which is here. So that's the plan for today. I wish you a fruitful stay here. And Tomek, if you are ready, the floor is yours. Thank you very much.
Thank you very much for the introduction, and in today's presentation I'm going to present you the review of the research with the participation of experimental station in Skierniewice, and the review of the research will be focused on about the data collected in the projects we were participating and the projects are now finished. And the exemplary of the projects we had in the past was focused, for example, you can see the names of the projects, Azomice, with the low input and environmentally friendly system for fertilizing and sowing corn. Then we had also the Connect Farms as a connecting sustainable agrosystems and farming with circular bioeconomy, and the Biofood on Mars, the project about the biofortification, then the climate resilient food and fodder. And also there was projects about the biogas production and digest evaluation in the context of the value, the fertilizing value. And we are here in Skierniewice, and the experimental station is named after Professor Marian Górski. And as you could see several minutes ago, this picture is representing all fields in Skierniewice, and you can see the codes A, D, and E with random monocultures and 5 field crop rotations. The fields, they are different, and the fields A, they are fertilized without the organic addition, but only there was like a change of the experimental design in the past, and some of the strips, they are fertilized with the manure, with the addition of the manure, A4, A5, and AF2. And the next part, from A9 to A12, they are the plots. They are with the participation of the legume. So in in the crop rotation we have a legume, but here we don't have the legume. And the monocultures, there is a set of the mineral and organic treatments with the control and the lack of one of the main elements, and the 5-field crop rotation as the most sustained system of production. With the legume, last time it was mainly lupin, and there are also potatoes with manure applied every 5 years. And here you can see the general view of the experimental design. So here you have like first part, non-fixed crop rotation without legume, and the codes of the fields, as you can see on this picture. And we are testing 2 different mineral nitrogen forms, the ammonium nitrate, and then there is a field with ammonium sulfate. And you will see today what the impact of ammonium sulfate on the field conditions is influencing. And there are combination with the control as a permanent 0. So it means there was like for the last 100 years 0 added fertilization, and the combination full and unbalanced combinations. And another part is the second part, A6, A8A, with the lime as a control and unbalanced mineral fertilization system. And for example, you can see lack of lime, lack of nitrogen, lack of potassium, lack of phosphorus. And then fixed crop, non-fixed crop rotation with legumes, A9, A8, 12. There is ammonium nitrate nitrogen source, and the control is a lime. And then you can see the extra 5 mineral combinations, unbalanced, and we are testing them. The level of fertilization of nitrogen is today is 90 kilograms per hectare per year, 26 kilograms of phosphorus per year, and 91 kilograms of potassium as a potassium chloride. And the third part, you can see the 5-field crop rotation, also with the ammonium nitrate and the crop rotation, and also the treatments, mineral treatments we have on this part of the experimental fields. And also monocultures, D5, 6, and 7 with ammonium nitrate. And we are testing the treatments with and without application of manure. And there are like 2 options. Every year applied manure, 20 tons per hectare, and every 4 year applied manure, 30 tons per hectare. And here in Skierniewice, we have infrastructure. You can see the microplots and greenhouse. In this system, this is kind of like a microplot system, where we have a connection with the ground soil, groundwater, and also we can remove and we can fulfill a new soil for our purposes. So there is plenty of this, let's say, ceramic cylinders, and for our investigation purpose, we can set the microplots according our question. Also, we have a greenhouse and this kind of pots called as rhizoboxes, so where we can evaluate and assess root system development, as you can see on the picture. So we were testing the different solutions of deep placement fertilization, and then we could extract root system. It was the extraction using the water, and with that scanner just scanner plus software, we could scan and evaluate the root system development. Here also we have the pilot line for organic manure pelletizing, and before we also composted many different organic sources like chicken manure, cattle manure for the Connex farm purposes, and also we were adding the straw of Miscanthus giganteus and also some percentage of the biochar, both from the market. And also you can see our book, the result of our work in our university. This book in Polish is about the fertilizers from waste and the possibilities of the alternative source of nutrients in agriculture. And you can see the first example of the project, the biogas and the digesters evaluation. And there were like 2 research projects, publications, and the evaluation and testing yield effect. So you can see the like simple small unit of the methane production, the stuff controlling the parameter, and then we were able to put some any different kind of the organic source, and then evaluate the efficiency of methane production. So from organic substrates, as you can see, the liquid phase after anaerobic digestion, and we had the digest. And then after separation and pelletization, we had like ready to be applied the pellets. And for example, 40,000 tons of the let's say raw material brought us approximately 33,000 tons of liquid phase, and the rest was only the solid phase. And here you can see the example of the results we received from our experiments, the maize fresh yield per plot from different digests. And we had a control and the slurry applied, and different digests after the methane production. DW125, it was like a farm and agro-industrial residues versus farm residues only. And you can see the relative effect very comparable to the slurry, or even higher than the yield under slurry application fertilization we achieved. And then there was also another topic, the enhancement of the efficiency of nitrogen was raised, and the national project we had in the past, and it was about the deep placement technique of application. And I would like also to say many thanks to our colleagues from Germany, because in the past, the professor Karl Sommer from the Bonn University, he received the title Doctor Honoris Causa from our university, and he was a pioneer of the coltan technology of fertilization. And in the Azomaize project, we manufactured in Puławy the super granules, as you can see, like 10 centimeters in diameter, the fertilizer, and the starter one, like a traditional 4-5 millimeters in diameter. And also we designed and we manufactured the machinery for sowing and applying deeply these both fertilizers on the different level as a starter and the deposit fertilization one time applied. And also, as you could see, the evaluation was done in the rhizo boxes in the context of the root system development. And we were like checking the yield response, nutrients uptake, root system development, and environmental impact of that system. And here you can see the, the main yield from 2014 and 15, field data expressed in tons per hectare. And the treatments we were testing: 80 kilograms of nitrogen applied broadcasted versus 20 kilograms of nitrogen applied on the top, and 100 the same amount applied deeply, and 160 kilograms applied on top. And you can see the differences and the positive response of our system, the deep fertilization system. The key indicator was that the middle dose, 120 kilograms of nitrogen applied at depth, yielded approximately 95–96% of the nitrogen dose applied here, applied in the dose of 160 kilograms. And also we had an extra yield of silage and grain, and also we saw that the positive effect was very strongly related to the vegetation conditions. And 2015 there was like a severe drought, and we couldn't see a positive benefits of that system. So that means we can have the advantage of this system under more wet conditions. And also the data from the pot experiments, you can see the yield of the potato tubers and from variants of the fertilizer application, surface 10, 20, 30 centimeters deeply applied, and the highest yield we have under 20 centimeters depth of application, and the modification of root system architecture. And then the different location brought us the response of the root system parameters. You can see the root length and root surface, so very crucial parameters in case of water absorption and nutrient uptake. So you can see that the tendency, the increase, and the longest total root system over 4,000 centimeters, and also the increase of total surface of the root system. In Skierniewice, we have also energy crops, and you can see 3 examples and the yields. The highest coming from the Miscanthus giganteus, and also we have a willow and Virginia fan petals. And the response of the yields, you can see the variance CA NPK versus without NPK and without liming. And what is interesting, you can see the decline was different across the different species. The most sensitive was the willow in the context of lack of NPK, and what is the typical in the case of energy crops growth, they are quite resilient to the acidification of the soil, because the yield was reduced by 6–7%. And another example and explanation of the response of the energy crops to the lack of the elements, because you have here the relative scale yield decline expressed in percent relative to CA NPK. All of them, they are the most sensitive to the lack of the nitrogen, but there is like also diversity in the case lack of potassium. For example, Miscanthus and Virginia, they declined the yield between 15 and 70%. And in case lack of the phosphate, the willow was the most sensitive. And also based on our experience, we formed the threshold values for diagnosis. So you can see for each plant, for each species, we have a data, we have a numbers for the diagnosis of the nutrition status of these three different energy crops. Another topic was the question about how to improve the phosphorus availability in the soil. And the project was about the sulfur-coated phosphate rocks. So we have patent of this research and of this data. And of course, the problem is every year only 50–25% the plants are like utilizing and exploring the applied phosphorus. But the question is, for example, in organic farming, we cannot apply too much like phosphorus available, and we have to use the phosphate rock. And the idea was to find the solution to increase the availability of phosphorus. And we coated the phosphate rock with sulfur, molten sulfur, and then after application to the soil and application of sulfur oxidizing bacteria Thiobacillus oxidans, the sulfuric acid was a product of the reaction between phosphate rock and sulfur. And then the result was the increased availability of phosphorus. And you can see the data from pot experiments and yield out, and the comparison between, for example, here you have a control variant and the best response from superphosphate, 27 grams per pot. But what is interesting, you can see the phosphate rock applied with a 30% mass of sulfur added and relatively comparable results, benefits we received from our like idea and our research. And that means this system can be implemented in the practice, but of course we have to have sulfur and bacteria. Another topic was related to phytoliths as a very, very stable form of the carbon sequestration. So each plant has some content of phytoliths, right? But the species, they are relatively different. And we were testing different treatments as a mineral plus silicon applied as a foliar application. This is the market available product, Optisil. We were testing also the compost plus silicon, NPK, compost plus selenium. And what we received, you can see the kilograms of equivalent of CO2 per hectare. And the maximum sequestrated carbon dioxide we received after application of mineral plus silicon applied on top, right? This was above 40 kilograms sequestrated kilograms of CO2. And also there are relative differences between species and between the part of the plants. You can see the grain versus straw. So the straw is the richest material, plant material with the phytoliths. So if we would like to increase, stabilize CO2, this can be like one of the implementation, one of the solution we can do into the practice. We do have also field measurements, as I had mentioned yesterday. We have a portable spectrometer, Picaro, and the closed chamber technique we are using, and we are evaluating the greenhouse exchange between soil and the atmosphere. And this year published data about the CO2 emission and methane uptake under buckwheat vegetation. And what we could observe and publish was that you can see the like quite obvious tendency after manure application. There was like increase of the activity of the soil, and relatively the highest cumulative CO2 emissions, as you can see. But this field was under ammonium sulfate nitrogen strip investigation. And in case of NK, NP, there is a severe acidity of the soil. And you can see all of the mineral treatments unbalanced. They were like emissioning a lot lower CO2 than, for example, with manure, or even you can see the balanced mineral treatments very comparable with the treatments with addition of manure. And also all the time we are observing the methane uptake. So we have a light soil, sandy soils, and the air diffusion into the soil makes it possible that the methanotropes, they are consuming the methane. And in the field conditions, when we are measuring, there is like a decline of the methane content in the chamber. And also, you can see the example of the evaluation of the biodiversity of microorganisms here in Skierniewice. You can see the test CHOW first, which means it is related, it is about the general diversity of prokaryotic and eukaryotic organisms living in the soil. And what we observed here was that the prokaryotic diversity was declined by the unbalanced NP-NK mineral fertilization system, but generally increased eukaryotic diversity under the treatments with the manure applied. Also, we investigated carbon storage potential in Skierniewice. So you can see the different horizon, the first, second, and third, and the treatments, two different treatments, mineral versus organic. Yearly applied mineral fertilization versus annually applied manure, 20 tons per hectare. And you can see the differences and carbon storage capacity and potential, especially the first top layer, 0.25. 5.7 versus 10.6 grams of the carbon per kilogram. This is the difference after 90 years of the experimentation in Skierniewice. Because the nitrogen is very correlated with carbon, also the same tendency you can observe here. We are also collecting the drainage water, leaking or percolating the soil profile, and we are analyzing the concentration of the elements. The most abundant element leached in Skierniewice was also, of course, calcium, and this is typical. Here in Poland and in this part of Europe, the conditions, the pedoclimatic conditions are like impacting, and we are losing every year the alkaline elements. So we have approximately 500 millimeters, and 20% is like percolating and leaching the elements. So you can see the relatively the highest amount, around 120 kilograms per hectare. Also, you can see the differences between elements, magnesium, potassium, sodium, and for example, what is typical, you can see liming versus non-liming combination, and acidified conditions, they are like making and the leaching on the higher level. So you can see the numbers and differences. Also, we see the leaching of micro elements the same combinations with lime and without lime, and the leached microelements. Of course, this is the cons of this conditions. But for example, in case of heavy metals, we don't have a problem, for example, with cadmium, because the soil mostly they are acidified, and cadmium is dissolved and then leached throughout the soil profile. And also you can see the aluminum level to be leached, relatively the highest from the most acidified conditions. Also, we did the investigation and evaluation of the level of aluminum available in the soil. And we formed the reaction of the plants in the fields from the lowest below 20 ppms, and we don't observe any reaction. And then there is like a impact of the aluminum on the composition changes, deficiency symptoms, strong symptoms, and then sometimes there is like complete lack of plants. And the level of 80 ppms is a threshold, and also Ca aluminum ratio below 1:1 is also threshold. And you can see the example of the acidification, ammonium sulfate plus potassium chloride, and this is oat, quite tolerant plant against the acidification, and the mineral treatments, and like there's like almost zero plants. But what is interesting, you can see the extension of this field here. You can see this is the same combination of mineral fertilization, but the difference is only there is application of manure. Every 4 years we are applying their manure, and there the oat looks like normal vegetation. And in the middle you can see the pK system and also the impact of acidity and acidification, and the same scenario with the manure treatment. But the mineral combination Ca and pK is bringing us like a normal yield of the oat here in Skierniewice. This year we have a potato on these 2 strips, and you will see what is the impact and how the plant reacts to all of these combinations. This is all I wanted to share with you. In my eyes, the most interesting results we collected and also published from Skierniewice. Thank you very much.
Thank you. Thank you, Tomek. If you have any questions, I would propose to move the discussion on the overall discussion, summarizing the conference, okay? So I would like to invite Aneta Peżanowska, who will take us to Chelice, 30 kilometers from here. These are also 2 very, very nice experiments. One of them is fertilization experiment, 70 years old. And the second one is the tillage experiment, 50 years old. Aneta, the floor is yours.
Okay. Good morning. My name is Aneta Peżanowska, and today I would like to present you some short information about also long-term field experiment located in Chelice. I work in the Department of Agronomy, and together with my team, Irena Suwara, Professor Leonard, Dr. Agnieszka Ciesielska, and Anna Wysmułek. I would like to introduce you to the experimental field in Chylice. You can see these places in the photo on the slide. And I will present you some information about the nature of the research that has been and is being conducted in this location. On the slide, you can see the location of a field experiment in Chylice. The field experiment in Chylice is located about 40 kilometers from Warsaw, from the Warsaw University of Life Science campus, and also on similar distance from here, from Skierniewice, also about 40 kilometers. And some historical outline of the field experiment in Chylice. The field experiment in Chylice is also the old field experiment owned by the Warsaw University of Life Science in the first 2 decades of the 20th century. And as you can see, the Chylice Agriculture Experimental Station was the oldest farm at the Warsaw University and became the formal and university became the formal owner of this place in 1921. And the first experiments in Chylice were organized in the beginning of the 20th century by Professor Józef Mikułowski-Pomorski. But since 1951, in the middle of 20th century, at the initiative of Professor Mieczysław Birecki, numerous field experiments have been conducted in Chylice. And the Chylice field was intended to serve as a training and internship base for students and for research and teaching staff to conduct experiments and research related to agriculture. This is also a very important place for our university. Since 1951, several departments of Warsaw University of Life Science have conducted their experiments at Chylice place. And you can see the changes over years in the numbers of field experiments. As you can see, the 1970s saw a boom in field experiments in Chylice. But in the following years, the numbers of experiments decreased. This was due to the fact that at the beginning of the 2000s, a decision was made to concentrate field experiments here in Skierniewice, in this location. And on this slide, I listed some selected thematic sections of the ongoing field experiments of the Department of Agronomy with the main organizers, authors of the experiments and research conducted. The largest number of studies in Chylice were conducted by the General Soil and Crop Cultivation Team. And the research topics like tillage, traditional and reduced tillage, and its consequences, irrigation, fertilization, and plant protection in tillage system, frame lines in a field, different post-harvest tillage techniques, methods of increasing the fertility of light soil, crop rotation and monoculture, fertilization and plant protection, weed biology and chemical weed control, plant water use and physical properties of soil are still relevant. Yes, now. Of course, let us remember the employers of our Department of Agronomy created the history of the experimental field in Chylice. Professor Birecki on the left, author of first field experiment in Chylice in the middle of 20th century, and other authors of field experiments with different topics and different problems. Professor Śmieszchalski, Dr Dreze, Professor Alicja Gawrońska-Kulesza, Professor Domańska, and other authors of researches. And Professor Trzecki in Laboratory of Soil Physical Properties in Warsaw. And research problems and their effects in numbers in the table. Over the years, numerous scientific papers, doctoral theses, habilitations, and hundreds of theses written by the student in the Warsaw University of Life Sciences have been developed based on the field experiments conducted at the Chylice experimental site. And this table summarizes the results of the research work of the General Agriculture and Plant Cultivation team, the part of Department of Agronomy, which was based on the field research conducted in Chylice. And as I said, of course, the hundreds of diploma theses written by the students over the years. Picture. On the picture you can see the numbers of field experiments in the past, in 19th, and now in 2026. Only three long-term field experiments remained in Chylice. Only three. 2 field experiments with different fertilization regimes and 1 long-term tillage experiment. And the photo, the satellite photo shows the area where these 3 experiments are located. And of course, around the experimental field, normal agriculture production is carried out. And the first 2 experimental fields in Chylice, field experiments in Chylice, Z3 and Z4. On the picture, you can see the location of these 2 experiments with different fertilization regimes and crop rotation. These 2 experiments was established in 1955. And you can see on the slide the authors of this experiment and also currently research supervisor, Professor Irena Suwara. The aim of the experiment is compare the effect of organic and mineral fertilization and different crop rotation on soil fertility with infestation and also, of course, yields. As you can see, the fertilization methods used in both experiments are mineral, only organic, farmyard manure, mixed organic and mineral fertilization. And these 2 field experiments, in these 2 field experiments also treatment, unfertilized treatment is used since 1955. And the differences in crop rotation also you can see in this photo, in this slide. In experiment Z3, a legume, red clover, is grown every 4 years. In Z4 experiment, winter rapeseed is grown at the same time, and selected soil properties and winter wheat yields under different fertilization and crop rotation were presented yesterday by Professor Irena Suwara in Warsaw. So only short information about these two experiments. And in the picture you can see the response of sugar beet plants to the treatments in the Z3 experiments. On the left, mixed mineral organic, in the middle zero control without any fertilization. And I see, excuse me, this is my mistake. On the right, it is the effect of mixed, yes, fertilization, organic blood and mineral fertilization together. And on the right, the response of winter wheat plants to the treatments in the Z3 experiment. So we can see that long-term different fertilization influence the crop grow. And the third experiment located in Chylice, this is the tillage experiment U6. The letter U, this is the first letter in the Polish word uprawa. It means tillage in Polish. In experiments Z3 and Z4, the name of these experiments is connected with Polish word zmianowanie. In English, it means crop rotation. So short name, but we know what work in this experiment, U and Z and Z. And the experiment, tillage experiment, were established in 1975. Also like Z3 and Z4 located in black earth. And in Z3 and Z4 experiment, only traditional moldboard plow were used and are using now still. But in this kind of experiment, we use different tillage systems. Conventional moldboard plow and no tillage. And authors of experiment and currently research supervisor me. And of course, this experiment was established to determine the impact of long-term tillage systems on crop yields with infestation, because it can be a problem in reduced tillage systems, and also soil properties, physical, chemical, and biological soil properties, especially focused on light soils, yes, sandy loam. And in the picture we can see the location of this experiment U6 with different tillage systems. This is the same location like Z3 and Z4, located on black earth, and the black earth in all its glory. In conventionally tilled plots, you can see on this photo black color. Yes, in the middle, in this largest picture. And on the right, you can see the effect of reduced tillage systems, no-till with residue cover, and reduced cultivator tillage on the right also, with still visible crop residues after cultivation. But we know that the results of tillage intents differ, especially the residues cover on the soil surface. And we know that this cover protect a soil health, yes, biological life, and another soil quality indicators. And the scheme of this experiment and treatments, the conventional tillage and no tillage, this is the long-term tillage practice in this experiment, because this kind of tillage are from 1975. But in 2011. Some fields with conventional tillage and no tillage were replacement by reduced tillage with cultivator. So now we have 4 treatments: long-term conventional tillage, long-term no tillage, and also medium-term conventional tillage replacement by reduced tillage, so reduced tillage after conventional, and also no tillage replacement by reduced tillage. It is reduced tillage after long-term no tillage. Cereals, rapeseeds, maize, legumes with predominance of cereal crops are cultivated in crop rotation. And now I would like to present you the research potential of long-term field experiment in Chylice. And one information, of course. Excuse me, now. So, long-term field experiments in Chylice and the principles of sustainable agriculture are listed. These practices on the slide. I think that these practices listed on the slide are used in our field experiments. You can see the list: reduced tillage, maintaining appropriate levels of crop residue on the soil surface, applying crop sustainable rotation, sustainable methods of fertilization, plowless tillage, manure application. You can find these management practices in our field experiments. And you can, these experiments give us a very important information about the influence of this kind of practices in the long-term perspective. Of course, we invite you to collaborate on research based on these 3 field experiments located in Chylice. And I have listed some topics on the slide, but of course, this is only a small sampling of the various possibilities. As you see, we can check a lot of things very important in the current time under the climate change also influence. And the example of the international collaboration, the SOMPAX project. SOMPAX project under the European program GP Soil, which supports the sustainable practices. The project title was Soil Management Effect on the Soil Organic Matter Properties and the Carbon Sequestration. And yesterday, Professor Leinweber from Rostock presented us some information, some results from the project. And this is the example of collaboration, yes. So, thank you for your attention. Dziękuję za uwagę.
Dziękuję, Aneta. Thank you very much. Now I would like to invite Beata Michalska-Klimczak. Dear guests, I would like to underline one thing about Skierniewice. As far as I know, Aneta, you can correct me, the tillage experiment in Chylice is the oldest tillage experiment in Poland. Yes. Tillage experiment of such kind. Yeah. So this is also unique. Yeah. Another uniqueness of our station. Okay, let's move to Miedniewice, which are 2 kilometers from here in this direction. You saw it probably from the bus. Yeah, I heard about this. This is our youngest one, and Beata Michalska-Klimczak will tell us some details. The floor is yours.
Thank you very much. Ladies and gentlemen, I would like to present the experimental field in Miedniewice, which is a part of the research infrastructure of the Department of Agronomy at the Warsaw University of Life Sciences, which is located near Skierniewice, as you can see on the slide, and is situated approximately 2.5 kilometers east of Skierniewice. It's very, very close from here by walk, 10-15 minutes. The site covers a total area of 31 hectares. In 2010, a separate experimental area of the Department of Agronomy was established. As you can see, this initiative was led by three professors, Professor Zdzisław Wyszyński, Professor Lenart, and Professor Wiesław Mądry from our institute and our agronomy department and biometry department from our institute. The experimental field in Miedniewice is located on Luwi soils according to WRB soil resources. Locally, these soils are classified as rainfall glade podzolic soils. Here you can see the scheme of the field in Miedniewice. Whole experiment covers 8.2 hectares and consists 11 fields, as you can see, each approximately 0.6 hectares in size. Here you can see. The experimental field is organized into three main cropping systems: intensive, integrated one, and ecological cropping systems. The intensive conventional system is based on three field crop rotations, including winter wheat, oilseed rape, winter wheat, and spring barley. The integrated sustainable system follows a four-field rotation with sugar beet, spring wheat, legume crops. You can see soybean or lupin. It depends if they are in the long-term experiments or on the additionally field, and winter wheat. The organic cropping system also uses a four-field rotation, including sugar beet, spring spelt wheat with undersown red clover, and winter spelt wheat. One of the most important parts of the experiment is a part with long-term experiment. It is carried out within the intensive and integrated cropping system, as you can see. The experiment compares three tillage approaches: conventional ploughing, reduced non-inversion tillage, and simplified non-inversion system. In the third treatment, no tillage was used until 2019 and was replaced by strip till from 2020 onward. As you can see, the example of plot with three replicates on each of the tillage system. What we also have is a certified organic area. It's a very important part of our field experiment. It covers 4.2 hectares, including arable land and also permanent grassland. You can see the area of each of the arable land and permanent grassland. This area, what is important, has a positive opinion from the Regional Inspection Authority, which allows parallel organic and non-organic crop production for research and educational purposes. What is very important, the experimental field is used for a wide range of agronomic studies. Now I would like to show you the important studies which we have on this field. The first one and one of the key research topics conducted at the field concern the effect of different tillage system on crop rotation on soil quality. These studies focus on several important indicators, including the stability of soil aggregates, water-air properties, and selected physiochemical, chemical, and biological soil properties. As a part of this research area, a doctoral dissertation is being carried out by Szymon Młynek, he is here, and the supervisor, Professor Irena Suwara, our dean of our faculty. Yes. Another important topic and project which we have on the field is concerns the effect of tillage system and crop rotation on the yield and quality of selected field crops. These studies include the assessment of crop productivity, yield components, and quality parameters such grain, seed, or root quality depending on the crop species what we have. Also, we have studies on weed infestation are also very important, where we evaluate weed species composition, weed density, weed biomass, as well as the relationship between weed pressure and crop productivity. Another very important crop and project which we have, it's sugar beet. The research includes experiments on seed priming, as you can see, field emergence, canopy trait, root yield, technological sugar yield, and also we focus on the influence of harvest date, harvest method on root yield and technologically quality of sugar beet. What I would like to also add that these studies are conducted in cooperation with Kutno Sugar Beet breeding company. Moreover, I would like also give you example of the very interesting project what we now have on the field. Is conducted with cooperation with our Institute of Biology and Biotechnology from our university. This project focuses on the development of an innovative technology for improving the quality of uncoated and coated seeds of sugar beet, maize, oilseed rape, and carrot. This project is implemented in cooperation with Nanotech Polska. Additionally, we also have studies on the use of microbiological fertilizers preparations, which are conducted on the fields. This experiment focus on the response of crop plants to bacterial products and their effects on plant growth, yield formation, and selected quality traits. Research which we have conducted on the certified organic field has been conducted on the productivity and quality of crops grown under these cropping systems. One group of studies focus on 3 wheat species: common wheat, spelt wheat, and durum wheat. Another one research topic concerns vegetable crops, including zucchini and onion, with particular attention paid to yield and quality traits. Moreover, an ongoing project is currently being conducted, a project which is called OnFine, which aims to improve knowledge transfer and innovation in organic farming by creating a European network of farmers, researchers, advisors and producers supported by field trials, training activities and digital tools. You can see the link to the website of the project. Additionally, I said that on this organic field, we also have grassland species. Research on forage crops and grassland species are conducted with our colleagues. One of the study focused on the yield performance of Festulolium bruni in seed production under organic management. Another one research topic concerns the forage value and yield performance on perennial legume grass swords under different use intensity in organic and conventional farming systems. I would like also say that our research conducted on the experimental field in Skierniewice has resulted in scientific publications in journals such as Plant Soil Environment, Agronomy, Agriculture, Antioxidants, Foods, Journal of Water and Land Development. But also I would like to add that apart from its scientific function, our experimental field in Skierniewice also plays important educational role. It is used for field classes, student training, diploma thesis, and demonstration of different crop production systems. The field also supports doctoral research and scientific meetings organized especially by the Department of Agronomy. In the way it combines long-term research infrastructure with practical education in crop production and sustainable agriculture. What I would like to also add that our experimental field in Skierniewice is very important because it allows long-term comparison of different crop production systems and tillage methods under the same environmental conditions. This is particularly valuable for assessing changes in soil properties, crop productivity, and yield quality over time. The field also supports research on sustainable agriculture and provides a practical teaching base for students and young researchers. Therefore, it is not only a research facility, but also an important educational platform of our department, Institute of Agriculture, and our university. Thank you very much for your attention.
Dziękuję, Beata. Thank you very much. So this is the field in Skierniewice is the youngest one in our experiments, but it's also very interesting. So you know all our long-term and let's say mid-term experiments, and we would like to invite you to cooperate with us. You know what we have, and if you are interested in some collaboration with us, please contact Tomek Niedziński if you like Skierniewice, Aneta Perzanowska, Professor Irena Suwara if you would like to cooperate with some topics related with Chylice, and please contact Beata Michalska-Klimczak or Krzysztof Pongowski if you would like to cooperate with some topics related with experiments in Skierniewice. So you are invited for this cooperation. And as for the offers, also we have we have such offer that this place, the station, is a perfect place to organize some meetings with schools for advisors, agricultural advisors, or people related with agriculture, because on our fields here, you will see it in hour, 2 hours. We can perfectly see the effects of fertilization on plants. Yeah, so it's like in a handbook. Yeah, you can see it very clearly. So we are open also for such a cooperation like this. Okay, let's move to the let's say closing ceremony, or I would say, I would name it like this. Excuse me, I will do this like this. No, this is not the presentation. Okay, first I would like to sum up the conference and say thanks to many people, or companies, or institutions. So I would like to thank all our patronates. Yep. I would like to thank for honorary patronage of Ministry of Agriculture and Rural Development, Ministry of Science and Higher Education, our rector, marshals of Województwo Mazowieckie, Warsaw is a part of this województwo, and also I would like to thank Marszałek Województwa Łódzkiego, Marshal of the Łódzkie Województwo, where Skierniewice is located. We thank our media patronage, Polish TV, Top Agrar, APRA, and the Farmer. Thank you, all of you. Also, I would like to thank our partners which supported us financially. These are Geomortechnik, which is, for example, which sells, for example, Ekelkamp devices. QED, the company which will show the presentation of their product called Conspectrum. Do we have QED representatives? No, they are in the field. They are preparing the presentation. Intertech Poland, which is which sells, for example, the products of Picarro. Very nice machines, for example, machines for devices for isotopic analysis. Isotopes, I think, are the future of our studies, because they can clearly show you the difference or origin, for example, of methane, for example, by the comparison, by the ratio of different isotopes of carbon, for example. Yeah. We would like to also thank AgroSimex, Agrotechnology, QZ Solutions. We have Mr. Zbigniew Kawalec on the hall, and also we would like to thank Małopolska Hodowla Roślin. Many thanks for my colleagues from organizing committee. I would like to thank Stanisław Samborski, Tomek Niedziński, Kinga Noras. Many thanks. Our layout. This is the idea of Kinga. So I think you will remember this this pattern. Yeah. So this is the Kinga's ideas. Aneta Perzanowska, thank you also. Paweł Szacki, thank you for the preparation of our station. What we have here is an effect in the last years. This is an effect of development by Paweł, and all you can see here is an effect of Paweł and his team here. Yeah, there are 5 people here. Paweł is a head, and also there are 4 more people working here. I think Damian Murach, he is absent because he's in China, but he also did some effort in the organization of the conference. I would like to thank our conference table yesterday, Mrs. Monika Golonka, and our PhD student, my PhD student Karolina Feluch, and our students Patrycja Delińska and Adriana Tokarska. You met them yesterday during the registration. Thank you very much to all of you. I would also like to thank the staff of my institute, because apart from the people mentioned in the last slide, also many other people from my institute also organized this and this in the conference. Also the PhD students were engaged in this. Thank you very much to the staff of the station once again, and also I would like to thank the staff of organizing committee of the event, which was organized before the conference on Thursday. It was the 120th anniversary of the Faculty of Agriculture and Ecology, led by Professor Irena Suwara. So this week we have a marathon of events since Wednesday, when we had a very nice agro games contest for students. Then Thursday, the anniversary of our faculty. This is the oldest faculty of in our university and the oldest agricultural faculty in Poland. And yesterday and today we have the conference, so this is some kind of marathon. Also a few people from the committee, organizing committee of the anniversary of our faculty were engaged in the organization of this conference. I would like to also once again acknowledge the honorary committee of the of our conference and our faculty jubilee also. These are Professor Andrzej Radecki, Professor Sławomir Podlaski, who is here, Professor Jan Łabętowicz, who is also here, Professor Zdzisław Wyszyński, who is absent today, and Professor Grażyna Garbaczewska. These are the former deans of our faculty. I also acknowledge the contribution by scientific committee of the conference. These are 33 people from Poland and from abroad. Thank you very much for your contribution, and some of you are participants of the conference. So thank you for being here. Thank you very much. This was a real international conference. The representatives of 7 countries from all over the world, from 2 continents, are here. So I'm glad that you are here. We have people from Czech Republic or Czechia. I don't know which option you like more, but I read that both are good. Yeah. Germany, Hungary, Lithuania, United Kingdom, United States of America, and Poland. As for the Polish universities and institutions, the representatives of these 17 universities and institutions from Poland took part in this conference. Yeah. The most numerous group was, of course, from our university, Warsaw University of Life Sciences, Szkoła Główna Gospodarstwa Wiejskiego w Warszawie. Thank you, all of you. I would like to thank all participants for being here and all the discussions, presentations, posters, and so on and so on. Thank you very much. I didn't tell about this. I was thinking if I should, but I would like to propose you to publish your presentations in these journals. This is like this. These journals have announced their that they are ready to publish your results. But articles will be subject to normal, typical journals, standard editorial and review procedures with all the consequences of this. Yep. These are Polish Soil Science journal, the left one, Soil Science Annual, and more chemical, more elemental journal of elementology. The Soil Science Annual is led by the Soil Science Society of Poland, and the Journal of Elementology is a journal from Olsztyn, North Poland. Okay, so these are the, I think, all acknowledgements. If I forget about anybody, I would like to apologize, but I think I acknowledged all that deserved this. So I would like to propose some discussion as a summary of the conference. Yesterday I proposed to answer a few questions about the long-term experiments. As you remember, I think that this conference is a very nice occasion to discuss the issues related to long-term experiments in Europe and the USA also. I think that the role of the long-term experiments is not very well known in the public. I think so. I'm not an expert in this. You are much greater experts. I deal with some research in long-term experiments since a few years. There are many of you who are dealing or building your whole career on this. But from my point of view, from my side, I think that the role of the long-term experiments is underestimated. I think so, both in the public and institutions that finance the long-term experiments, the decision makers, yeah. And we can discuss this problem. What are the reasons for this? Maybe we should organize more such conferences to spread the information about the long-term experiments, what they are, what is the aim of conducting of these experiments, what information can they give, yeah? how to use it in practice. Yeah, I think that I like the work by Cenk Donmes and the team because they you probably also do this, and also probably Andy and your team are doing this. I mean the long-term experiments are very big, huge source of data. Yeah, about the soil, about the crops, about the in the context of weather conditions also. And these materials can be, for example, this information can be, for example, used to build, for example, strategies for the development of agriculture in many countries. Yeah, the strategies based on the scientific basement. Yeah, not just said from the air, yeah, invented from the air, but set in the really scientific basement. We can discuss the status of long-term experiments in your countries. Also, what are what's going on in this matter? Yeah, what are the problems and challenges which you face? Yeah, in your countries. And I don't know what do you think about the idea of networking of long-term experiments? Because I think that this is, I think, so good idea to network the long-term experiments. I mean, I think I'm thinking about Poland right now, but maybe in your countries there are such networks. If you could say something about this, how it works in your countries. In Poland, I think we should start the discussion about the networking of our long-term experiments. I think it could be useful. I think it could start from the inventarization of what we have. Yeah. Then the next step is to standardize the methods of managing data. Yeah, taking and managing the data, and this basement could be an opportunity to cooperate with long-term experiments each other. The people who take care the experiments can contact. And for example, I don't know, think about the projects, international or Polish projects. Cooperate with stakeholders, companies to develop some, for example, solutions like you will see in the field in 1 hour. Yeah, I mean the innovative methods of, for example, checking what is the nutritional status of plants. What do you think about this idea? These are only highlights. Stanisław Świtek.
Yes, so
Przedstawiajmy się. Let's introduce ourselves. Yep.
Stanisław Świtek from Poznań University of Life Sciences. We saw it that we have some patrons of the media, agriculture media. There is any journalist on the hall here?
No.
No, so this is the problem. We should cooperate closer with the journalists. I try to write some articles based on this conference to the agriculture media, and I hope so I will share with you with those information. Thank you.
Thanks. Thank you, Stanisław. Yes, it's true that the media representatives are absent today, but we are in contact with them. We prepared the text for them in order to spread the informations which we would like to spread. Yeah. So. pokazało się już? Tak, publish? Że opublikowali? Yes. Yesterday there were representatives of the media. Yeah, maybe it's because today is Saturday. Yeah, I don't know. But we are in contact, and we would like to spread the information in Farmer, in Top Agrar, also on our websites, in our university, and in many places. Also the TV. I would like to thank TV. I'm sorry, I forgot about you. So, these are Marysia and Jacek are the people who will spread the information about the conference also. Thank you very much for your work. Thank you. Yeah, this is the important thing, I think. The long-term experiments will be much more famous, and the public will be more acquainted with this once we will show it in media, yeah, different media. Bidesh, yeah. Would you like to have a microphone? Yeah.
I think yesterday, I'm Bijesh Mahajan from University of Nebraska. Yesterday also there was a question in the room, somebody asked a presenter, what's the novelty in your long-term experiment? It seems like you are just repeatedly measuring same old thing in the same old place. But the thought I have is, we all know the impact of Killing's curve, right? That continuous measurement of atmospheric CO2, how that single plot has informed our science and research and society. So for me, the biggest asset we have is with the long-term monitoring is that lasting impact of any agricultural practices. So that's where I see the potential. That's why yesterday also I challenged the room, can we make impactful statement like Killing Curves does to us? Can we gather all the long-term experiment? The gist of most of our research is really the underpinning is the soil fertility. So probably we already have collectively 1,000-year worth of data to really make a lasting impact on our society and ag research. So that's where I see the value of LTE, that continuous measurement on the same old practices and same old ground. So with that in regard, I feel like networking is a key. We have to continue meeting across worldwide. I think it's been happening, and thank you for inviting all of us here. I think we need to sit together more regularly, more closely to discuss how we can really make lasting impact out of these experiments. So on that regard, I want to do a plug-in for our friend in Illinois. In Illinois also there is a long-term experiment, and they are celebrating their 150th anniversary in October. So Andy, Cenk, and myself, we all are tentatively going to that meeting. So please come to that meeting, and there the agenda is not the data reporting. They are really trying to address some of these key questions. What are the challenges with LTEs? What are the design experimental changes you are doing in your LTEs? How you communicate and connect with the policymakers and the society at large. So they are trying to address those pieces that you are trying to spur the discussion here. So yeah, October 29th and 30th in Illinois. Andrew Marganet, many of you probably already know him. So yeah, that's what I wanted to share. Please keep in mind the Keeling curve, we might be capable to bring forth something that's sort of impactful reporting from our LTAs one day. Thank you.
Thank you, Bijesh. I probably also will be on the conference in Indiana, but yeah, we will see. Another words in discussion or thoughts? Professor Józef Chojnicki.
Hello, yes, working. In my opinion, the last point, networking long-term experimental sites as idea, it is a very good idea, not only in scale of the national network, but also international network should be created, and exactly such meeting like now we are. It is a good occasion for make first step in this direction activity. It is, I think that such closer cooperation will create a bigger effect of promotion, long-term experimental fields, will create it higher possibility to get some projects, because financial problem, it is also very important, sometimes not enough money for leading such experimental field plots, and also the promotion by scientific conferences, this idea, the idea of long-term fields plots, by conferences, by publication as papers in different journals, and also in social media in other way, we can get success, and we can develop in this way not long-term field experiments. Thank you.
Thank you. Do you have any more ideas? Andy? Please.
Hi, yeah, Andy Gregory from Rothamsted in the UK. Yeah, I agree with everything that's been said so far, really. Rothamsted is a research institute rather than a university, so the kind of system back in the UK, I guess, is that the research institutes have a bit more of a strategic, long-term vision, I guess, compared to universities, which might be shorter funding cycles. So that gives a degree of protection, I guess, for something like the Rothamsted long-term experiments, which are almost kind of funded as a national facility. But it is something that we have to keep applying for every 5 years. We're about 2 years off our next applications. But it's basically making the case that, demonstrating that they're still valuable, that research is being done. I would say our experiments are still very much kind of scientific, for scientific research, perhaps rather than demonstration outside. And it's making the case, that the research that's been going on today is really a result of all that investment that's come over all of that time, really. And I often kind of think in my own head, the soil samples that we will collect after the harvest this autumn, what will be measured on those in 40 or 50 years' time? We don't know, but we think something important will, because we know what we're doing now with reanalysis of archive samples, let's say, or interrogating data sets. So I guess it's just trying to make the point to funders about how important these are, the investment that's needed, that they can't be recreated very easily. And we look for opportunities, I guess, to work together again, like the SOMPAX project, for instance, EJP. That was a nice opportunity to link LTEs. Yeah. Point number 5 would be great nationally if there was some way of bringing your LTEs here within Poland. like you say, kind of, even if it's just inventories, what treatments are there, what data you have, what samples you have, and kind of going from there, really.
Thank you, Andy. Any more thoughts and impressions, etc.? I can't see, so maybe we are hungry and we need to eat something. Okay, so I would like to thank you once again. Thank to all the people who organized this. Thank to our TV, and thanks to you that you decided to come here by the ocean sometimes, and thank you. So I would say that we can close our conference, our official part of the conference. Now we would like to invite you to the lunch, but maybe first we can take a photo outside outside the building on the right, on the stairs. Jacek, czy jesteśmy przygotowani na zdjęcie? Może byśmy wyszli teraz zrobić zdjęcie, a potem jeszcze w polu. Tak, nawet z drona, w polu to nawet z drona, nie? Bo nie dyskutowaliśmy tego dzisiaj, więc dyskutujemy teraz. So we are discussing about the photos. Okay, so let's go outside for a while, for a minute or two or five, take the photo, and then there is a lunch, and after lunch at what time? At 2 p.m. we will start our trip. If the lunch will be shorter, we can start the trip even shorter, if you like. So I will ask right now. Maybe we could start, I don't know, 1:30? 13:30? Okay. I think that we don't need hour and a half to eat. Yeah.